Hi there, welcome back to Pretty Much Flawless. Today we have part 4 of a 5-part video series, and today we'll be working on designing a PCB. Let's get into it. Wow, these PCBs look so great!
We got him cornered.
Boy, where are my PCBs?
You'll never get that information from me.
Time up.
Gotta make this delivery.
Is there something I've been forgetting? Oh, this video is sponsored by PCBWay. PCBWay makes high-quality custom PCBs for your projects. Design and upload your Gerber files to the website, then place your order and wait for your PCBs to come. And that's not all they do. PCBWay also does PCB assembly and does CNC machining, 3D printing in many different materials, sheet metal fabrication, and injection molding. Check out their website. There'll be a link to that in the description down below. Do you have a neat project? Or do you want to see some neat projects? Check out PCBWay Community. And if you are looking to make your own affordable PCBs, I would really recommend using PCBWay and look forward to using them again in the future. Alright, so we have our schematic drawn, our new parts ordered, and our footprints designed and assigned. Now what we can do is open up the PCB editor here, and we have all our components here. So what we're going to do is we are first of all going to draw an outline for our circuit board. So our original circuit board was 71 by 91 millimeters wide. And now what we can do is we'll select our QC tabs and we'll just move them out of the way for right now. And now what we'll do is we'll lay out our relays how they would be on the board. So alright, so that's all the relays laid out now. And what we can do now is we can lay out all our QC tabs. So what we'll do is we'll select our QC tabs that have to go along the top here. And we'll move them down. And we'll get the first one spaced out, and we'll get the last one spaced out here. We'll get them all spaced out how they are. It's a little bit messed up, the ordering of these. We have 1, 2, 4, 3. Alright, so now we have them in the right order. KiCad has a pretty neat tool where you select all your footprints here. You right click, and then you go over here, align/distribute, and then we're going to hit distribute horizontally. So that'll get perfect spacing all along between the first and the last one. And we'll select them all again. Same thing again, and we'll hit align to vertical center. Perfect. And we have all those right where we want them. I'm going to move them up a little bit. Alright, it looks really good. And we'll do the same thing again for this side and this side down here. Alright, so we have all our components laid out. Now we need to start connecting the traces. So what we're going to do is we're going to take a look at our old board, and then we're going to kind of see what sizes of traces we need, and then we'll run some calculations just to make sure everything makes sense. So we're going to look at our old board here, and we have 3 different sizes of traces. One of them is 8 millimeters. Another size of trace is about 4 millimeters. That trace kind of carries anything that needs power around. There's another size of trace that is 1 millimeter, and that looks like it just carries around signal power. So all the relays are connected by traces this size. And there's one more trace that is 1.5 millimeters wide, and that powers a cooling fan. So what we can do is we'll go over and use a PCB trace width calculator. We can enter in our current, our copper thickness, our allowed temperature rise, our ambient temperature, and our trace length. So what we can do is we can start entering information. So first of all, we're going to do some calculations. Our board powers heating elements, and there's 3 heating elements it powers, but only 2 are ever in operation. So each heating element, cold, is about 25 ohms. So using Ohm's law, what we can do is we'll take 240 volts divided by 25 ohms equals 9.6. Now we'll multiply this by 2 equals 19.2. So what we can do is we can enter in 19.2. This is also kind of worst case scenario. This is when the elements are cold. As soon as the elements get warmer, the resistance will go up, and that will decrease the amount of current they take. So what we can do now is we can enter in our thickness of our board. What we're going to do is we're just going to type in 1. This is ounce per square feet. And then we can enter in our temperature rise. 10 degrees is normally a good temperature rise. Our ambient temperature will enter in 30 degrees Celsius just because this is above an oven, so it might get a little bit warm. And then the trace length will do 171 millimeters just because this is our board length. This is worst case scenario. Most of the traces are shorter than 171 millimeters. We're going to convert this to millimeters here since I'm using millimeters. So we're just going to worry about the external layers and air calculation over here. Internal layers is for if you have a more than 2 layer board PCB, then what happens is you start having layers internally kind of sandwiched in between the top and the bottom layers. And basically, you need wider traces for down there just because there's less cooling than if the layers were in air. So since our board is just a 2-layer board, we don't have to worry about this calculation over here. And you can see that it has to be much wider for being in the internal layer than in an external layer. So you can see that our required trace width is 17 millimeters, and that is fairly big. Like, that's a pretty huge trace. So what we can do to cut down this size is we can change the thickness. So 1 ounce is normal if you're designing a smaller board, but if you're doing a more of a high-powered board, you can change the thickness. So I'm going to change this to 2 ounces, and you can see this kind of cut our trace width in half, but this doubled our vertical copper height. So what we can do with this here is we will bump this up to 9 millimeters just to give us a little bit of buffer room. And then what we can do is we can draw our trace out here. So first of all, what we're going to do is go over here to track, edit predefined sizes. And then what we can do is add a track width here. Okay, here we go. And this is going to be 9 millimeters. Okay, so now we have the added in. We'll hit OK. And then what we can do is we'll hit this one over here, 9 millimeters. Alright, so then we'll hit route traces here. And we'll just go straight across here. Okay. So that's a big trace right here. And now what we can do is we can do some more calculations. So then for our slightly smaller traces that connect all the power to the relays, we can run a calculation there. And we kind of already did, but we can just do that again. So our cold temperature for our elements is 25 ohms. Using Ohm's law again, 240 volts divided by 25 ohms is 9.6 amps. So enter in here 9.6, and our required trace width is 3.4 millimeters. We'll bump this up to 4 just to give us a little bit extra capacity, and we will reroute here. Okay, so same thing again. Alright, so we have all the main power traces done. And next what we can do is we can work on the signal traces. So what we'll do is we'll go back over here to our calculator. Each relay, the coil draws about 300 milliamps. And there's only about 3 coils on every wire like this. So what we can do is we can do 0.3 times 3 equals 0.9. So that's almost 1 amp here. So what we can do is we'll just give ourselves some room. We will make this way overkill. 4 amps, we'll just round up to 1 millimeter. This is definitely oversized. The original board had about this size of trace, and we have plenty of room on our board, so we'll just make this a little bit bigger. Alright, so what we're going to do now is we'll make a neutral plane. So what we need to do is we will select the bottom layer here, and we'll select add a filled zone. And what we'll do is we'll select our net, which is for neutral here, hit OK, and now we'll draw our plane here. Good, and now we'll hit the B key, and that fills it all in here, and that's very good. So, good, so you can see that all our neutrals are connected, and this is on the bottom layer, so that's good. Alright, so we have our board here now, and what we can do is we can run a DRC check, just to make sure everything's okay here. And everything looks good here, so we'll close this, and everything looks very good, which is good. So the next thing we're going to do is we're going to draw some lines so we can help identify which pins are for what. So what we're going to do is we'll go over here to the upper silk screen here, and what we'll do here is we will draw a line straight across here. Alright, so now we have to do something that I should have done earlier, but I forgot to. I should have done it before all the traces were laid out. So what we're going to do is we are going to add holes in the board here, because we don't want our board just resting on the surface of something. We want it to be held up by something. So it's going to be held up by plastic pegs, and we need holes for those plastic pegs to go into. So what we're going to do is we will select edge cuts here. First of all, we're going to measure out where our circle is going to go. So, and then we'll take our circle here, and we'll start right at the middle point here, and then we want our radius to be 1.5 millimeters, just because we want our circle to be 3 millimeters. So alright, now what we'll do is we'll select our bottom layer again, and we'll hit B, and what that'll do is that'll add a hole, just so the copper isn't right up against our hole. And now we can go over here to the 3D viewer, so we can see that the copper isn't right against our hole here, and that should be good there. So, alright, so what we can do now is we can generate our Gerber file. So now what we can do is we can generate our Gerber file. And if you install the PCBWay plugin, you can just click this. Alright, so then it will open up here in PCBWay with our Gerber file already uploaded here. And then what we can do is we can select how many pieces we want. We can select how many layers. This is obviously a 2-layer board. We can select what kind of material we want. Select the thickness of our board. Minimum track spacing, and then the solder mask, so what color the board would be. And I'm actually going to make this board red, like the look of red here. So what we're going to do, we'll keep going down here, and the surface finish will make this lead free. And for the finished copper, so then I'm going to change this to 2-ounce copper. You can do bigger copper. I have it designed for 2-ounce copper, and it also costs more the more copper you add. And that's about it for this board. So what we can do is we can order this, and then it should come soon. Thanks for watching this video today. Hope you learned something. If you did, please subscribe. That would really help my channel, and I'll see you next time.